Okay, 6D. In a titration experiment, 100 milliliters of sodium hydroxide is added to 200 milliliters of 0.4 molar moronic acid. We're at equivalence. What equivalence means in this case is my moles of hydroxide that I've added equaled the moles of the acid that I started with. And I want to know the pH at equivalence. So I have the acid reacting with the base to form the conjugate base and water. The whole point of equivalence is these two moles are the same, so these both end up being about 0 at the end. However, we are making a significant amount of the conjugate base, and therefore that base is going to make the solution basic at that point. So I need to figure out how much base we formed. If we have 200 milliliters of 0.4 molar, 200 milliliters is 0.2 liters. That gives me 0.08 moles. So I had 0.08 moles of this, 0.08 moles of that by definition. We're going to make 0.08 moles of HX or of XO2 minus. This is a weak base. So I'm going to need to do a KB expression, treating that as a weak base, which means I'm going to need its molarity. In reality, I should be writing the reaction with water of that weak base. Which is what makes that KB expression I just wrote valid. All right, I have 0.08 moles. My total volume, 200 milliliters, 100 milliliters, adds up to 300 milliliters. 0.08 divided by 0.3 gives me 0.267 molar. Now I need to find the KB for this base. Earlier, I found Ka for the weak acid. So I'm going to do Ka times Kb equals Kw, or Kb will equal Kw divided by the Ka, which is 1.73 times 10 to the negative fifth. So 1 times 10 to the negative 14th divided by 1.73, 10 to the negative fifth, gives me 5.8 times 10 to the negative 10th. Okay, so that number times 0.267, square root of my answer, gives me an X value of 1.24 times 10 to the negative fifth. Negative logging that will give me the POH, since that's equal to my hydroxide concentration. And then subtracting from 14 gives me a pH of 9.09. For E, I need to pick the right indicator. I want an indicator that changes color as close to this point as possible. So to do that, I'm looking at their pKa values, since that tells me at what pH they'll change color. Well, which of those is closer to 9? Probably 9, making phenolphthalein the correct choice for this titration.